Hello everyone. Today we are going to solve this equation given by 5 to the power p minus 3 to the power p equals to 98. So how to solve this type of equation? Okay. First of all, what we can do, we can note here that since 5 to the power p is always greater than is never 0. Okay. 5 to the power p is never 0. Okay. Since 5 is greater than 1, 5 to the power p is increasing. Okay, increasing function. It is never equals to 0. So what we can do, we can divide this 5 to the power p by 5 to the power p, means entire left hand side by 5 to the power p and right hand side by 5 to the power p. Then what we will get? So just divide this one. That means left hand side and right hand side by 5 to the power p. Then what we will get? 98 by 5 to the power p. Now since this denominator 5 to the power p is never equals 0, we can do this. That is, we can divide this 5 to the power p both sides. Now this, what is this? This will get cancelled and it will convert to 1. And this will get as 3 by 5 whole to the power p equals to 98 by 5 to the power p. Okay, now what we can do, we have to know what is this. Is it increasing function or decreasing function? Similarly, is it increasing function or decreasing function? Okay, by definition, first of all, we must know the definition of increasing and decreasing. Okay, definition. So for sum a between 0 to 1, if our function is a to the power x, then it is decreasing function. Okay, because a is less than 1, so function a to the power x is decreasing function because it will decrease, it is less than 1. Suppose a is your 1 by 2, it is less than 1. Okay, or 3 by 5 similarly. And for a greater than 1, f of x a to the power x is increasing function. Okay, this definition we must all note that for this range function is decreasing function and for this range function is increasing function, and that is why we have taken 5 to the power p, because 5 is greater than 1, so 5 to the power p or 5 to the power x is increasing function. It is never equals to 0, hence we are able to do this, that is divide by 5 to the power p both side. Now what we will do, we will use this one, because we can clearly note here our a is 3 by 5, 3 by 5 to the power x, it is decreasing function. Okay, this side. Now what we can do, again we can rewrite the equation here. Our equation is 1 minus 3 by 5 to the power p is 98 by 5 to the power p. Okay, now this one is of the form a to the power x or a to the power p, and a is less than 1, hence what is this? It is nothing but decreasing function. Decreasing function. Okay, so 3 by 5 to the power p is decreasing function. Now what is this? We know that 5 to the power p or 5 to the power x or a to the power x is increasing. if a is greater than 1, 5 is greater than 1, so 5 to the power p is increasing function. That means it's reverse, it's reciprocal. 1 by 5 to the power p is what? Decreasing. If 5 to the power p is increasing, 1 by 5 to the power p is decreasing, and that means any constant into that 1 by 5 to the power p is obviously decreasing. So this function is decreasing function. Okay, so we can see again that this 3 by 5 to the power p is decreasing function, and this is also decreasing function. But since this is decreasing function, but 1 minus this decreasing function will be what? Because negative of this decreasing function. This is not decreasing, this is decreasing, and 1 minus this is also there, LHS. So this entire LHS is what? Increasing. This entire LHS is increasing function, but RHS is decreasing and LHS is increasing. That means if both of them will meet, they will only meet at just one point. Okay, and we have to find out that one point. How to find out? We have to give logical explanation. So what we can do, we can take this one to this side. Okay, 3 by 5 to the power p to this side, and then both the decreasing function will be at one side, and one side it will be a constant function 1. So now what we will do, we'll shift to this side. Now shifting to this side, we will get this one. Okay, 1 equals to 3 by 5 to the power p plus 98 by 5 to the power p. Now this is decreasing, this is decreasing. Sum of these two decreasing function will again be decreasing. Okay, this we can easily show. How we can show? By calculus. If we'll take this as function, its derivative or first derivative will be negative, and that will show, because summation of derivative is derivative of summation. We can show this one also. If we'll take this one as f of x or f of p, if f of p is 3 by 5 to the power p plus 98 by 5 to the power p, what we can get f dash p as? We will see it will be negative. If first derivative is negative, we'll get this as decreasing function. Okay, so how we'll show this? Derivative of this means d by dp of 3 to the power p by 5 to the power p plus 98 by 5 to the power p, and this is nothing but d by dp of 3 to the power p by 5 to the power p plus 98 times d by dp of 1 by 5 to the power p. Then again what we can do, this one as 5 to the power p whole square. This is nothing but 5 to the power p into derivative of 3 to the power p. What is derivative of d by dp of 3 by the power p? Is 3 to the power p into log 3. Similarly, minus 3 to the power p, derivative of 5 to the power p. What is that? 5 to the power p into log 5. Okay. Similarly, here also we will do the same thing. 5 to the power p whole square. That is minus of 5 to the power p into log 5. Here we will see that 5 to the power p into 3 to the power p common, which is 15 to the power p, and it is log 3 minus negative log 5. Obviously it will be negative because log 3 is less than log 5, and this side is already negative. 98 into 5 to the power p log 5 by 5 to the power p whole square. Okay, this is negative, this is already negative, so we will get off negative of some term. We will get something like this to 5 to the power 2p. This is all no matter, just you have to see that this is negative, so this is less than 0. Okay, so if f dash p is less than 0, so we can say that this function, this decreasing sum of the two decreasing function is again decreasing function. Okay, now we will see that this RHS is decreasing, this RHS is decreasing, and LHS is nothing but a constant function. Okay, just we can graph this function, how the graph will look like. We can say that at x equals to 0 or p equals to 0, this function is 3 by 5 to the power 0 plus 98 by 5 to the power 0. And this is nothing but 98 plus 1 is 99. So here something like 99. And as p tending to infinity, this will tend to 0. So our graph will look like this one. Okay. And this is our RHS function, that is 3 by 5 to the power p plus 98 by 5 to the power p. This graph is this, and LHS will be our 1 constant function, and they will meet at just one point, this point, and this point only we have to find out. Okay, so how to find out? We can just use the trial and error method. It is also possible. Just we have to note that this is only single solution. Only one solution is only possible. We have drawn this graph. Okay. And this graph and one constant one will meet at just one point. So only one solution is possible. So what is the solution? So for the solution, again, we have to look at that equation. 5 to the power p minus 3 to the power p equals to 98. And since only one solution is only possible, we can guess that solution. It is no hard, it's nothing hard. We can take, if p equals to 3, if p equals to 2, it is 5 square minus 3 square, it's 25 minus 9, it's 16, it's not 98. So if p equals to 3, we can see 5 to the power 3 minus 3 to the power 3 is nothing but 125 minus 27, and that is equals to 98. Okay, so we got, by trial and error method, 5 cube minus 3 cube is 98. So for p equals to 3, we are getting, and we know for only single solution this is only possible for a single point. So solution is only p equals to 3. Okay, this is solvable. So thank you. Subscribe for more such content. Thank you.